Hey guys, welcome to today's video. In this video we are going to solve one more LeetCode question which is from top interview 150. So this question, even I have got this question in most of the interviews. This is very frequently asked question in an interview, and I think the interviewer in this particular problem is looking for how and like what type of data structure you can use to get this done. Okay, so let's understand this. So the question is LRU cache and the question number is 146. So the here LRU means least recently used. So and it comes under medium. So let's understand this question. So here it is saying design a data structure that follows the constraint of the least recently used, means which is if any item you are putting in a list or any kind of data structure, if you're putting the items and if it is not used very a long period of time, and suppose you have 10 spaces, or in a data structure only 10 items you can accommodate, and if you add the 11th item, so the oldest item should be removed from the particular list. So this is what the least recently used means. So it is saying implement the LRU cache class, which is present over here, and they have given three methods which we have to write. One is the constructor, initialize LRU cache with positive size capacity, int get. So usually in the caching, how it works, you put the data and after a certain point of time when you need it, you retrieve it. So there are two operations. One is get, return the value, the key if it exists, otherwise return -1. And the second one is putting that data into the cache, which is the key and the value. So I think for simplicity it is only int we have to deal with. Update the value of the key if the key exists, otherwise add key value pair to the cache. Okay, this is, I think it is the same way how the map works. If it is not present, it will add it, and if it is already present, then it updates the value. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Okay, the functions get and put must each run in O of 1 average time complexity. So this is one of the constraint. One thing you have to notice over here, you have to keep in mind, is that when you put the element, you are using an element, but if you get also at that time also you are using an element. Okay, so these two functionality like we need to take care. Now let's understand the question. So here in the input there are three sets of string. One is LRU cache. This means you are initializing the constructor. This will get called. For put will get called, and for get operation, get will get called. Okay, for LRU 2 means the capacity is 2. So for put is 1 and 1, so which means the key is 1 and the value is also 1. Now for second put is also so the key is 2 and the value is also 2. Okay, now we do the get after it, right? So get of 1 means like you're passing the key as 1. Okay, so in the LRU cache, first you added you initialized with the capacity 2, you added 1 1 and 2 2. So till this point you have added 2 elements, and our cache capacity is also 2. So now after that you did a get of 1. Okay, so initially it is null null null, and then you do a get. So get of 1 you will return you 1, because there are 2 elements and you are getting one of them. Okay, now you added 3. Okay, you added 3, so you already had 2 elements and you have used 1. So it is just now we used it, even though we added it at the first place, but we used it, right? So now since we have only 2 places, so we need to add this and we need to remove any one of these 2. So which is the least recently used? It is 2, because 1 we just now used it in the get operation, right? So this 2 needs to be removed. Okay, now when we do the get operation for this 2, we get the -1 because we have evicted. Now for same reason, like 4, You have added 4 over here, and now the least recently used is 1, because just now we used 3, because just now we used 2 and 3 we have just now added, right? So these are frequently used right now, and 1 is not used. So now if you do get of 1, we will get -1. Now we do get of 3 and get of 4, because these 3 are present, so these 2 are present, so we got 3 and 4. Okay, hope you understood it. Now how we are going to solve it? So ideally we should solve it via doubly linked list, and we should implement the operations of getting, putting, and how to add an element into that particular doubly linked list, and how to and we should find out a way to make it recently used. Like, you have a doubly linked list, you add the elements towards the head and remove the elements from the tail, and whenever you use any element, you remove it from the tail and you add it to the head usually. But I'll tell you here for now one of the easiest option which is present in Java. Okay, but I am not sure like the interviewer is exactly looking for that, so we will deal that thing in the next part of this question. Okay, for this I'll tell you how to solve this if you are doing in HackerRank or LeetCode. So you can use this method, and which is equally valid, because we have some of the utility functions which is present in Java, which we should use, but the whole point of judging is judging the functionality of least recently used over here. So what we will do, we will create a linked hash map, and a linked hash map has a method which you need to override while creating the constructor, that if it reaches beyond some capacity, then you remove the least recently used. So I'll just take you through the Java doc. So if you see over here, this is the document for linked hash map. Okay, so linked hash map has a constructor which takes 3 elements: this initial capacity, load factor, which is usually always 0.75, and this access order. So it maintains the access order. If it is true, then you are maintaining the access order, and if it is false, then you are maintaining the insertion order. Okay, I'll show you. Okay, so if you go down the methods it has, so this is the one: remove eldest entry, returns true if the map should remove the eldest entry. Okay, this method is invoked by put and put all after inserting a new entry into the map. It provides the implementer with the opportunity to remove the eldest entry each time a new one is added. This is useful if map represents a cache, which is what we are right now doing. It allows the map to reduce memory consumption by deleting stale entries. Okay, so we need to copy this, and we need to implement this, and instead of max entry we need to add whatever capacity they are looking for. Okay, so let's use this. So I'll create a map of integer okay, I will initialize it to null, and I'll create a variable n over here, and what I'll do, this dot n is equal to capacity, and we will initialize our map over here. So we'll do new linked hash map, which will take the capacity, which is n. Okay, and the load factor is really this, and true for maintaining the access order. Okay, now you need to copy this this we need to override over here. You need to implement this. Okay, so instead of max entry you need to add n. So if it is more than the size, then you return. Now in the get operation you just need to return if map dot contains key, else return -1. We cannot directly return because this will return null and we need to return the end, so that's why we need to check for if this key is present or not. And in the put operation you need to do map dot put key and value. That's it. So this is the simplest one, but the main logic the interviewer will be looking for this, so we need to implement it via core data structure, which should be doubly linked list. I'll show you that in the next video. In this video, let's just solve this question. So it got accepted. Let's try to submit it. So it got submitted. So if you see over here, it is taking 43 seconds, but if you see other solutions, it is taking quite a lot less time. So we will implement that in the next video. Okay, thanks for watching. Bye.